Okay guys, here we go. Welcome to lesson 23 and 24. We're talking about graphical solutions. So basically what we're seeing here, the bottom line is when we have an x and a y, there's like three ways to solve for the x and for the y. We are solving with elimination, substitution, or by graphing. Honestly, by graphing is one of the least exact ways to do it, but it is important to know that you can do it that way. Okay, and then in lesson 24, we're going to be talking about fractional equations, which are pretty easy and fun, and some more things about triangles, which are always fun. Okay, so here we go, let's do it. This one says solve by graphing, so what you need to do is you need to graph these two lines, and then you find the point where they intersect, and that's going to be your x and your y. So the very first thing that you need to do, obviously, is graph it by putting the lines into the line format. So we need everything to be equal to y. So on the 3y minus 2x equals 6, we're going to have 3y here equals 2x plus 6 because we moved the 2 over there. Divide by 3, divide by 3, divide by 3, so y equals 2/3 x plus 2. Okay, then we go over to our graph. That means we're going to go 2 on the graph, right here. And we're going to go on the y, pair down 2 on the y, and then up 2 over 3. Up 2 over 3. 1, 2, 3. And then you can also go down 2 over 3. Because remember, you can have this as both positive or both negative in order to get a good line. Okay, then we solve for this one, for y. So y equals negative x minus 1. So that's a negative 1 over 1. That's invisible there, right? So we're going to go on our negative 1 here. Then we're going to go down 1 over 1. This way, because it's negative 1, positive 1. Or it's positive 1, negative 1, so we're going to go up 1. Okay, the problem with going this up 1 over 1 is that we haven't actually intersected with this line yet, but we're going to draw it, and we're going to assume where we're going to intersect right here. Okay, because up 1 over 1 again, you're going to intersect right there, and that's why, like I said, it's not the most accurate way to solve for x and y, but it's good to know. So now your point for x and y is what? Negative 2. And 1. Now, the way to check it though, you still need to check it, and you still should check it because that's going to tell you whether or not you were actually accurate or not, is to plug it into one of these. So we're going to go negative 2 plus 1 equals negative 1. Yes, it does. So we are super happy because it worked. Okay, so let's look at example 2. Okay, here we go with example number 2. You're going to have y equals negative 3. So I already put that line for you right there. And then we're going to find where it intersects on this one right here. We need to solve for y equals 2x plus 2. Okay, so we're going to start at the 2. We're going to go up 2 over 1, because there's an invisible 1 right there on the denominator. Down 2 over 1. But I'm going to keep going down 2 over 1 until I hit this line. Okay, so down 2 again, over 1. And then look, you're going to go down 2 again, and then you're going to go over 1. But here's what I'm talking to you about how graphing for solving is some of the most inaccurate way. There's not actually going to be a point, you guys, that this thing hits exactly. Because when you go down 2 over 1, now this one's going to hit halfway between a point. And you cannot accurately find exactly where that point is. Here in the book, they say you can estimate. You can estimate that it hit negative 2.5. It hit halfway between the 2 and the 3. But to me, when you're graphing and you find that it's not going to be completely accurate, you need to decide on a different method. And that's what we're going to do here. So I'm going to solve for by substitution. Y equals negative 3, so you're going to put that into here. Negative 3 minus 2x equals 2. Add your 3 over here, that's going to be 5, negative 2x, so it's negative 2 and negative 2. X equals negative 5 over 2, and y equals negative 3. And then you can put both of those in order to check your answer. So, I repeat, when you come to a graph to where it is not easy to see exactly what point hits that line, then use a different form. And for me, I don't care what form you use as long as you're getting the right answer, okay? So now we have our practice. We can do that really, really quickly because it's just one, and then we can move into lesson 24. Okay, here on the practice, you have y equals 2x plus 1 and you have x equals negative 1. So you already have your x, your answer for x, and you put your line x equals negative 1 right there. Then this is already solved for y, so you're going to put your 1 on the y-intercept, and then you're going to go up 2 over 1 and down 2 over 1, and you're going to see that you intersect right here, which is at negative 1, negative 1. So y equals negative 1. You can what's the word? Check for it up here, because you can put x as negative 1 into here, so that's going to be negative 2 plus 1 equals negative 1, which is what you got right here. So your answer is x equals negative 1 and y equals negative 1. Okay, let's get into lesson 24. Okay, lesson 24, here we go. The very first part of it is fractional equations. So look at this one. You have 4.5x minus 3/5 equals negative 1 and 1/4. In order to solve for that, there's one thing you got to do to simplify this type of problem first. What do you think you have to do? Make all those mixed numbers improper fractions. Okay, so here we go. This is going to be 2 times 4 is 8 plus 1 is 9 halves. X minus 3/5 equals 4 times 1 is 4. 4 plus 1 is 5/4. Okay, now this is what I like about these, because I do not like working with fractions, but in these kinds of problems, it's easy to get rid of those denominators and get rid of the fractions. You look at your denominators, guys. 2, 5, 4. What is the common denominator between all of those? What is the smallest number that each one of those can go into? Como, like if you were going to be sumando them, right? And you needed a common denominator. Okay, what would your common denominator be? Well, it would be 20. Okay, why? Because 5 times 4 is 20. We know that's going to be the very first number that all of them can go into. If you need help finding the least common denominator, let me know, and I'd be glad to help you with that, because there's a few different strategies with it. Okay, so what we're going to do is I put that number 20 up here at the top. Up here and up here, above each of the fractions, because then this is what I do. I divide. 20 divided by 2 is 10. 20 divided by 5 is 4. 20 divided by 4 is 5. Okay, and then I rewrite my equation by doing what? By multiplying 10 times 9, 4 times 3, 5 times 5. Because what you're doing, you guys, is you are multiplying that 20 to each of the fractions to get rid of that denominator, okay? Because it's what's really going on behind the scenes. You did 20 over 1 times 9 over 2. Well, what happens? You cancel out your 2 and 20 and it becomes 10, and then you multiply 10 times 9, okay? That's what's happening behind the scenes when I write 20 and then cross all that out and write 10, 4, and 5. So here we go, 10 times 9 is 90, x, minus 4 times 3 is 12, just don't miss your minus, and 5 times 5 is actually negative 25, obviously, because the negative's up here, so I forgot to bring it down. Okay, so then we just solve for x like normally. We put our plus 12 over there, so that's going to be a negative 13. 90x equals negative 13, so x is going to equal negative 13 over 90. Wait. Okay, now, just to let you know, because I said that, you know, the only thing that I actually hear is that you check your problems that have solving for x, right? Then what you want to do is, you do need to substitute that x into this equation to make sure that it works. However, I've already told you, I don't like to work with fractions. So here's what I would do. I would convert everything into decimals, right? I have 4.5 would be 4.5. 4.5 times, parentheses, negative 13 divided by 90, pardon. And you get negative 0.65. And I would just write that right here. So you get a negative 0.65 minus, and then I'm gonna, I deleted it after my thing, but I'm gonna put it back in. Okay, then I'm gonna put minus a parentheses 3 divided by 5 equals negative 0.125. And what does negative 1 and 1/4 equal? The same thing, negative 1.25. Okay? So that is one way to check it quickly. Okay? The other thing that you could do, honestly, is you could just check and make sure that you got this equation down here perfectly fine by going through your process again, right? It's 20, 20, 20, divide is 10, 10 times 9 is 90, 4 times 3 is 12, 5 times 5 is 25, and then substitute that 1390 into the x right there, okay? But you do need to be substituting in to make sure that you're getting those right, okay, you guys? So here we go, let's do our example 2. And you don't have to show all your work for checking them, but you do want to check them because you can check them on your calculator, but don't be lazy or don't have, falta de integridad, because there's a perfect way to check for those x's quickly, and you need to make sure that you can do that, okay? When you get into advanced math, sometimes the checking takes actually a lot longer than even the problem, and then we will get away from checking them like that, but not right now. It's not too hard. Okay, here's another one that we're gonna do where we just find the common denominator between 5, 2, and 3. That's gonna be, let's see, can't be 15.